All right. So just a few reminders. What I was going to say here was to just make sure you're checking your pacing. I checked yours. You're doing great. You're right on schedule. So that's good. So, and you know that checkpoint 9 has been exempted. That one was mostly just graphing, which we don't really need to spend our time doing graphing. Yeah. Okay, so today we're going to talk about systems of inequalities. That's lesson 11. We're going to talk about the vertex theorem. We'll just go over that to make sure we're good on that. We'll do some practice and go over that problem I looked at on your checkpoint 11. So here we go. So you hopefully have read this already, the vertex theorem. So take a look at that and read that and tell me what you think this means when you read this. You want to find the convex set of inequalities. Perfect. And when they say the convex set of inequalities, finding the vertices of the polygon, this is a lot like that linear programming we did in lesson 10, right? Where the lines, yes, exactly. The lines form a polygon and we mark the vertices. What do you think they mean by convex set? So what I was going to do here was have you draw a convex polygon on the board. What do they mean by convex? Do you remember what that is from way back in geometry? You should be able to draw on there. Oh, Jillian's here. Hi, Jillian. Welcome. We're just starting on lesson 11. We're talking about the vertex theorem. So why don't you pick a color, you guys, and draw a convex polygon on the board. See if you remember what a convex polygon is. I'll draw one too, since there you go. That's a. It's hard to do straight lines on the board. Let me draw one. You don't know yet what a convex polygon is? You remember this from geometry. Polygon is just a multi-sided figure, right? What does convex mean? I have this one is a polygon, right? It's, I don't know, 1, 2, 3, 4, 5. It's 6-sided. And what if I had one that looked like this? Is this one convex? No, remember, so concave is if it all, yeah, this one's concave, right? When it has a thing that dips in like that. Remember that? Okay, and convex is when they all sticking out. Oh yeah, remember? Okay, good, perfect. All right, so if we have our convex polygon, the vertices are these things, right? The corners where the lines meet. So we're talking about the vertex theorem. In the vertex theorem, yes, the points, exactly, the points. The vertex theorem says if you want to find a minimum or a maximum value from a convex set of inequalities. So this means if you graph it and it forms something like this, it's not going to work. All right, so it's got to be a convex polygon. You find the vertices of the polygon that results from graphing the intersection of the inequalities. This is a lot like the linear programming we did last week. less than 10. Oh, Shannon's here. Hi, Shannon. All right, so today we're going to talk briefly about this vertex theorem, which is basically the theorem that we used last week on linear programming, but now we're going to give it a name, which says that if you graph a series of inequalities, if you check the vertices, that will give you some minimum and maximum values. Okay, so let's look at this one. We have 3 of you guys, so let's see. I'm just going to go down the line. We can have Bentley graph this one on the board, Jillian, and then Shannon. Guys, try to graph that on my little graph I put up there, and let's see what we get. Everybody should have drawing privileges. Let me check. Yep. Perfect, Jillian. That's y is less than or equal to 3. Okay. Just a horizontal line. Perfect. Shannon, can you do x is greater than or equal to -5? Wait to shade it until we get everybody else's lines on it, I think. Good question, though. All right. All right. Bentley, Shannon, you guys able to get in there and draw the lines? Having trouble, technical problems, let me know. That looks good so far. Bentley's got in that perfect. Y is greater than a -x plus 2. Bentley, if you have a greater than, oh, it's perfect. Shannon's got that one. Yay. All right. So a couple of things we need to remember just, all right. And then, let me see. Bentley used black to shade. Jillian, can you use a different color? And then Shannon, stick to your color. There you go. And don't forget, you guys, on this one and this one, right, these should be dashed lines or dotted lines, not solid lines. She got the shape perfect. Okay, where does all 3 shading overlap? All 3 shades overlap. The dashes, yeah, the dashes, those are dashes. That one's a dash, that one's a dash. Is that where it overlaps? Oh, that's Jillian's graphing, right? Less than or equal to 3. The black was Bentley, and the red was Shannon. So it looks kind of like this area, right? Is where our solution set would be. Yeah, perfect. All right. So we all remember how to graph inequalities because we're going to use that today. All right, and here's our next warm-up. We're going to talk about graphing inequalities. We're also going to talk about radical equations today, or radical inequalities. So let's look at this radical equation. Oh, you do? All right, great. We have the square root of x minus 3 is equal to 5. What would be our first step in solving this equation, A, B, or C? Jillian and Shannon went for A, Bentley went for A. Okay, so why don't we go ahead and solve it? I'm going to add 3 to both sides. I get the square root of x is equal to 8. What do I do next? Square both sides. So I get x is equal to 64. Does that seem right? Yeah. Okay. Square both sides. All right, so that's how we solve these radical equations. So we're going to be working with systems of inequalities today. So we're going to be graphing inequalities, similar to what we did last week for the linear programming. We're going to be working with the vertex theorem today, and we're going to do some radical inequalities. So instead of having an equal sign in our equations that we're going to be working with today, we're going to have an inequality. So if you guys have if you could open another window and open up your Desmos.com for graphing, like we did last week, let's do that again. Everybody have the window up or another window up? Yep. Okay. How about you, Bentley? Were you able to get Desmos.com? It's an online graphing calculator. Just open up another window. Okay. All right. So we're going to be working on solving systems of inequalities. This is a lot like what we did last week. So let's talk about our steps. First, we rewrite the equations so that a positive y, we need a positive y alone on one side of the equation. We graph each inequality on the same graph, just like we did. We shade each inequality where the shading overlaps is the solution set. So this is really similar to what we've been doing. But we're going to start talking about the vertex theorem, which says that if we make a convex polygon, we can check the vertices in the equation for the min or max values. So let's just warm up on graphing the inequalities. This is right off your checkpoint for checkpoint 10. So this is one of your questions. It says solve the system of inequalities by graphing. Okay, so I want you to try to graph both of those on your Desmos.com. We'll take a minute and see if you can graph them. They're already set up for you. Then we'll ask a question after you're done with getting the graphing done. So let me know when you've got them graphed up on your Desmos. Julian's done? Okay. Let's wait another minute for Bentley and Shannon. Bentley, I don't think you were here last week when we went through it, so you're done? Okay. All right. Shannon's finishing up. So while Shannon's finishing up, let's look at this. Shannon's typing. Done! Okay, all right, guys. Everybody look at your graphs and tell me which graph is the correct answer for that system of linear inequalities. Which graph? Circle it, mark it, right top or bottom in the chat. Perfect. Top first, top one. All right. All right, guys. So that's your basic graphic of inequalities. Perfect. Great job, you guys. Okay, so let's graph some more. These are a little bit more complicated. This is another one off your checkpoint. And it says the solution of the system of three inequalities is given by a polygonal convex set. So when it says polygonal convex set, that means it's the lines are going to form a polygon, and it's a convex polygon. So remember we talked about a convex polygon. something like that. You know, there's no dips in it. Can't do dips or anything that goes in that makes it concave. So it's going to make a polygon that's convex. So the first thing we need to do in order to graph this is rearrange these equations for a positive y. And you're going to get some funky fractions, if I remember correctly on this. And that's okay. So let's just assign these. See if you guys can rearrange them for a positive y. Anybody want to volunteer for number 1? I don't hate to just assign. Just going to do number 1. Rearrange it. That's okay. I'll put you up for it though, Jillian. You can do it when you get your piece of paper. All right, Shannon Bentley. Who wants to do number 2? Rearrange it so it's in the terms of a y on one side. Shannon, okay. Bentley, by default, you ended up at the bottom one. All right, so remember you want it to look something like y, something, dot, 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 right? You want just the positive y on one side of that equation. Rearrange it using your algebra techniques. Oh, hey, John, how you doing? Glad you could make it. When we first started, it was just Bentley and I. So I'm so glad everybody else made it. Bentley and me? I think maybe that's how I should have said it. Just a good thing I don't teach English. All right, so we're just rearranging these. We're working on what we're calling the vertex theorem, John, in lesson 11. It's a lot like the linear programming we did last week. So we're trying to get these inequalities set up so that it's a positive y on one side. The students are working on it. Anybody got an answer yet? Jillian's typing. Almost, okay. All right, Shannon's having troubles. Let's see, we'll have Jillian write hers up. Is Jillian in the green? Okay, well, Jillian write hers up, then we'll do Shannon's together. Are you, Bentley, are you in the black? You want to make sure you have an inequality sign here, not an equal sign. Something, there you go. All right, perfect. Jillian, this is number 1, right? She's y is greater than or equal to negative 4x plus 18. Beautiful job, Jillian. Perfect. Yay! Okay, let's do Shannon's while Bentley's writing his up. So we have negative 3x plus 6y is less than or equal to 27. Okay, we want to get the y all by itself. So I'm going to add 3x to both sides. And I end up with 6y is less than or equal to 3x plus 27. Okay, what do I do here to get that y all by itself? What am I going to do next? I'm going to divide. It's being multiplied by 6. We need to divide everything by 6 to get rid of it. See, when we divide by 6, these cancel out, and we just get them with 1. But when we divide by 6, we have to do it to everything, both sides of the inequality. So you end up with y is less than or equal to 3 over 6 is the same as 1/2, right? And then 27 over 6, can that get simplified? 9/2. 3 goes into both. We could just leave it as 27/6. It doesn't matter. We're going to put it into the graphing calculator. Okay, so this would be problem number 2 here. All right, Bentley. Where's Bentley at? Bentley, do you need help, Bentley, or are you doing okay? Okay. You want to do it all together, or do you want to put your answer up? It's going to be some funky fraction you're going to get here, so that's okay. Sure. Okay, so Bentley started with this one. Let me change my color so that Shannon, there we go, I'll use your color. Bentley started with this one. And so we want to rearrange that. So first we're going to add 7x to both sides, right? We're trying to get positive x on both sides, or positive y. So we end up with 5y is greater than or equal to 7x minus 18. Okay, we want to get y by itself, so what do I do with that 5 there, guys? What do I do with the 5? Yeah, the fraction, it is confusing, Bentley, because when I first did it, I thought, wow, I did something wrong because the fractions are really weird. But it's not, it's right. All right, what do I do with the 5 to get that one in its correct form? Positive single y. What am I going to do with the 5 to get rid of the 5? John's going to give me an answer here. Perfect. Shannon, maybe too. Being multiplied. So you want to do the opposite of multiplying to get rid of it. Divide. Perfect. Do the opposite. So if it's being multiplied, to get rid of it, we divide. So we're going to divide by 5 on both sides, every term. Right? So it becomes, the 5 over 5 just becomes 1. It's weird the way it does that sometimes. Jillian, she said she's having trouble getting her computer to type. I have that same trouble sometimes. Greater than or equal to, we're dividing through by a positive number, so we don't change anything with that inequality. 7/5 x minus 18 over 5. All right, you guys, we have 3 equations. We have this equation. Y is greater than or equal to 7/5 x minus 18/5. We have this equation. Y is greater than or equal to negative 4x plus 18. And we have this equation. Y is less than or equal to 1/2 x plus 27/6. Right? I want you guys to graph those 3 equations on your Desmos.com and see what you get. I know, but luckily you don't have to graph this by hand. You just type it into the system, right, into your graphing calculator. You can use any one. I like Desmos.com. It's free. It's online. But if you're, have a personal graphing calculator you like to use, that's fine, or a different one, that's fine too. Just so long as you can get the graphs. get them done, just let me know when somebody has them done. Okay, almost done. John's thinking about being done. Done. Shannon's done. All right, John, you beat me to it. All right, going on this next one. Check your graph. Which one which one of these is one of the values of the vertices? Which one? You're done. Okay, perfect. Here's, we should have a graph that looks like this when you got done. Is this what your graph looked like when you got done? This is what it should look like. Yes. Okay. Perfect. Even though they were really funky fractions, like Bentley's equation had really weird fractions, right? 7/5 x minus 18 over 5. You just got to trust that you did the math right? And you graph it. And surprisingly, it came up with this beautiful triangle, right? Which is a kind of polygon. It's convex, so we know it's going to work for us. And so we identify the vertices. And look, they're whole numbers. Isn't that nice? That's when you know you've done something right. So once we've got these vertices, and this is a question off your checkpoint, here's the rest of this question. The function f of xy equals 9x plus 5y passes through this set, the set that you just graphed. What values of xy give the function its maximum value? All right, so this is off your checkpoint for 11. I think it's the toughest problem on there. So which values would give this equation its maximum value? In the vertex theorem, where we're going to check our vertices. Ooh, the vertex theorem says your maximum or minimum point on a convex polygonal set, which is what we've got here, convex polygonal set, is one of the vertices. So you just throw your vertices into the equation and into the function and see which one gives you the maximum value. Convex polygonal set. Polygonal set. Okay. Check the vertices. So what do you guys get as an answer? Which one of these vertices makes this function the max? 9, 9, right? what values give this its maximum value. You check the value of this, you check this and this by dropping it into the equation. So 9 times 9 plus 5 times 9, what's that, 81 plus 45 is the maximum value. Okay, but it's asking you what values of x, y. So Shannon's correctly said 9, 9. The vertice that gives that function the greatest value. So that's what you would mark on that one. All right, so this is a lot like that linear programming we were doing last week. Okay, they just are putting a name to it. It's called the vertex theorem, and they're making sure you understand that it needs to be a convex polygonal set to make this happen. All right, I think I'm going to do radicals next. Okay, we're going to do radical inequalities. Somebody knows, what's a radical? Can you draw the radical symbol? So just put it up on the board. What do you guys think when I say radical? From a math standpoint, not from a political science standpoint. All right, perfect. That's a beautiful radical symbol. Anybody remember what the thing is that's underneath the radical symbol? What's that thing called? The numbers and things that would be underneath there. Anybody remember? If this is a radical, let's say I had something underneath here like 3x. What would that be called? Anybody remember? That's the radicand. So does this have to be just like the symbol? I think Jillian drew this one. Does this have to be just this symbol? Or is this also, if we put a little cubed root, is that also considered a radical? Yes. Or John, were you the one who drew this? Who drew the nice radical symbol? Yeah, it's John. Okay, great. Thank you, John. He always has straighter lines than I do. Okay, so, right, a radical is really just square roots, cubed roots, quadratic roots, fractional exponents, if you remember that. Okay, these are radicals. So we're going to start using radicals and inequalities, and there's just a couple of different things we need to do when we go to solve those. Well, we're going to do this as an example, and this is supposed to go all the way over. All right, so we're using an equal sign here. We're going to just practice with this one as an equal sign and then see what we do different for an inequality. All right, so here's our steps. First, we isolate the radical, which in this example is already done. It's all alone on one side of the equal sign. All right, second thing we want to do is define values that are not allowed by setting the radicand equal to 0. Or equal to, does that work for this one? That are defined values are not allowed by setting the radicand equal to or less than. Should be less than 0. Sorry, when I typed that last night. Define the values that are not allowed by setting the radicand less than 0. So remember, when we're solving radicals, we don't want to put negative numbers underneath that sign, underneath the radical sign. Okay, we're not working with imaginary numbers in this case. So we have to make sure that whatever value of x we get does not give us a negative value underneath that radical sign. So we set it as this being less than 0. Okay, so x less than -5 are values not allowed, right? Anything less than -5 is not going to be an allowed value, because that would make the expression underneath the radicand, a negative number. Does that make sense? So we would need to define our values that we cannot have. We cannot give ourselves a negative number underneath the radical. Okay. All right. So let's go ahead and square both sides. What do we get? Somebody want to write it up on the board? Go ahead and solve this problem for us. John, you feel like writing on the board? Why don't you go ahead and solve it for us up there? So just so I rewrite it, just so you, it's 3 equals the square root of x plus 5. This whole thing is underneath the square root sign. The x plus 5 is underneath the square root sign. Yeah, square both sides. Beautiful. All right. He squared both sides. He got 9 is equal to x plus 5. Now he's getting the x by itself. Subtracting 5 on both sides. End up with 4 is equal to x. All right. And if you drop that back into the equation, beautiful job. Thank you, John, so much. If we drop it back into the equation, that seems to work, right? If we say 3 is equal to the square root of 4 plus 5. So 3 is equal to the square root of 9. That works. And we look and we check. So we have to check our value to see if it works in the expression. And then we have to check our value to make sure it's not in this area, not allowed values. So x less than negative 5, we came with x is equal to 4. That's not less than negative 5, so we're good on all points. Just to let you know, sometimes when you're solving these radical expressions, either equalities or inequalities, you will get values of x that do not work. You have to go back and check them all. And those are called, anybody remember what values of x, if you solve a radical expression and you get a value that doesn't work, what that's called? Anybody remember what that's called? Called an extraneous solution. I typed it in there in the chat box. Extraneous solution. So you will get extraneous solutions when you do these things. So you need to make sure that you check each and every value that you get as an answer to make sure that it works. Okay, so let's try it as an inequality. We just solved it as an equality. John did a great job. Now this is off your checkpoint. It says solve this inequality. All right, so we already talked about the excluded values of x. All right, x had to be, could not be less than or equal to 5, right? Couldn't be that. Those are our excluded values of x. We solved the inequality. Okay, so let's try that. Did we do anything different? John solved it for us as an equality. Did we do anything different if we're solving it as an inequality? Did you do anything different? Nope. Only thing different, right, is you got to pay attention that you have an inequality. If you're dividing through by something negative or multiplying through by something negative, that inequality sign flips, right? In this case, there's nothing we're going to do. It's going to end up with, we're going to square both sides. 9 is less than or equal to x plus 5. We're still going to subtract 5. End up with 4 is less than or equal to x, or x is, oh, that's not equal to some, greater than, 4 is greater, x is greater than 4, or 4 is less than x. Okay. But let's talk about what we're going to do with this. So when you're normally solving an inequality, the first step you do is you find out what your excluded values are. And sometimes I draw a number line. Here's 0. Okay. Our excluded values is, if we were at negative 5 here, we couldn't have anything less than negative 5 as our excluded value. And the solution we came up with was that, oops, open symbol, that x was greater than 4. Okay, we really have 2 intervals here. We have this interval and we have this interval. Okay, and we have this interval in between. Where x has to be greater than or equal to 5 for that to be true. All right, so when you're solving inequalities, you want to test these different intervals to see if they work. You're going to just pick random numbers. All right, we know this one doesn't work. That's our excluded interval. How about the interval, though, where x is greater than 5? Okay, x is greater than or equal to 5. We pick a number in there. Let's pick 0, and we would put it into our inequality and see if it's true. Okay, so 3 is less than or equal to the square root of 0 plus 5. Okay, 3 is less than the square root of 5. What's the square root of 5? I suspect it's less than. John, I knew somebody would put it in a calculator for me. Okay, so we get 3 is less than 2.24. That is not a true statement, right? Not true. So we know this interval is not included in our solution set. So the difference between solving an equality and an inequality is we're going to come up with these solution sets, these areas where we need to test a value. Okay, and then our last one was x was greater than or equal to 4. All right. Or is greater than 4. Greater than 4. So let's pick a test number in there. Let's pick 5. Okay, so 3 is less than the square root of 5 plus 5, or 3 is less than the square root of 10. So 3 is less than 3.16. All right, so we picked a test number out of this interval of x being greater than 4, and we test it into our inequality, and we find that it's true. All right, so this is how we come up with this answer. X is greater than 4. But we have to check the different intervals. Okay, we have to define the intervals by figuring out the radicand value that's allowed. Then we solve the inequality, and then we have to test each interval. So let's look at it again. So let's look at this one. This again is off your checkpoint. Solve the inequality. What values of y are restricted under the radical? What values of y are not allowed? And you're going to get a fraction here, so don't be too scared off of that. Right, you can't have a negative. So 2y plus 7 must be greater than or equal to 0, right? 2y plus 7 must be greater than or equal to 0. It cannot be negative, right? So what values of y are allowed? What values of y are allowed? Let's go ahead and solve this inequality. Get a positive y by itself. 7. Somebody just go ahead and simplify that expression, that inequality. Y plus 7 must be greater than or equal to 0. So how do we get y all by itself in that equation? You would do both, Shannon. The first thing we'd want to do is subtract 7. Okay, so we'd end up with 2y is greater than or equal to negative 7. Then we're going to come through and divide by 2. We're going to divide by 2, John. We're not adding, so right, it's 2y. 2 times y, to get rid of the 2, we have to divide. end up with y is greater than or equal to -7/2. Does everyone follow how I got that possible interval? All right, so that's one interval that we're going to be testing into. All right, let's just go ahead and solve this one using our regular techniques. Okay, we're going to square both sides. Cancels out the square root sign, that all goes away. We're going to put 5 squared, which is 25, greater than 2y plus 7. All right, so go ahead and solve that for y, that inequality for y, and see what you get. Yay, Jillian. Sometimes I think if your bandwidth isn't strong enough, then you get, if you don't have a fast enough internet, sometimes it restricts you from doing the typing. It's just so slow. Yeah. All right. So hopefully we can get somebody who's working on putting this one in the form where you have y all by itself on one side of that inequality sign. Here. We're almost done. I'm just pushing people to get to the very last end of this question. I know you are super late. That's okay. Good to see you. We're always happy to see you. All right. Did anybody get this one solved? 25 is greater than 2y plus 7. So remember, we subtract 7 on both sides. 25 minus 7, that's 18. 18 is greater than 2y. Then 2 is being multiplied by y, so to get rid of it, we have to divide. And we get 9 is greater than y. All right, so let's draw our number line to help us visualize this. Here's our 0. You see -7/2, that's like -3.5, I think. And then we have our value of 9, all right? So here's our -7/2. So that came from looking at our restricted values under the radical sign, and then here came this answer, okay, when we just solved it. All right, so we have an interval here. We have from 3/5, y is greater than that, goes over like this, and then we have one also here where 9 is greater than, okay? So we have to test our values in both these intervals and see if any of them work. Right? -3/5 to 9, an easy one to test is going to be 0. Okay, so let's put a test interval from that one. So we say 5 is greater than the square root of 2. Instead of y, we're going to put 0 plus 7. Okay, 5 is greater than the square root of 7. Who's my master square root person? What's the square root of 7? .65. Okay, so 5 is greater than 2.65. That's a true statement, isn't it? So when we see that that's a true statement, that means this interval we found by restricting it, by looking at the restrictions, is okay. This one works. This one works in that inequality. So we have to make sure we include that in our solution set. Oops, this is this way. I misdrew that one. So let's look at the ones where 9 is less than y, or 9 is y is less than 9. Y is less than 9. I'm going to rewrite that. Y is less than 9. We could pick any value less than 9 to test that. Let's pick something like, I don't know, 5 maybe. 5 is, so we put it back in the equation. 5 is greater than the square root of 2 times 5 plus 7. So is 5 greater than the square root of 17? 4.12? So that's true, right? 5 is greater than 4.12. So we know this interval, the 5 was less than 9, that's okay. So if we look at our answers, whoops, our possible answers on this, we would rewrite this. I didn't give it the actual. Sorry guys, don't go dizzy doing that. Our answer set would be that y less than 9 and y is greater than or equal to negative 7/2. Okay, that's your answer. Okay, if you just went through and solved it, just like if it was a regular equality, you would just end up with that y is less than 9 part. Okay, and you wouldn't get this back half. You have to make sure that you test all your intervals. You wouldn't have gotten this part if you hadn't done the first step of checking under your radical sign. Oh, you get it. Okay. All right, guys, I know it's 10:56 and they've been here long enough. So everybody go out and have a great week. I really appreciate you coming in. Hopefully this week we talked about the vertex theorem and we talked about dealing with radical inequalities and how you have to check your restricted values underneath that radical sign. Radical, whoops, inequalities. All right, I'll have this up, you guys, in recording, and I'll post it up in front of lesson 11 if you want to watch it again. All right, so guys, go out and have a great week. Bye, John. Thank you. Thank you guys all for your participation. Poor Jillian's been in and out. Bye, Shannon. Thank you for coming. Aram, I'm glad you made it. Just watch the recording. That's okay. That happens. Just glad you were able to pop in. Bye, Jillian.